Hello, everyone. Good evening. I'm grateful to the Forum for Macroeconomics and Macroeconomic Policies and the Macroeconomic Policy Institute for the invitation. Thank you for the nice introduction, Tom. I appreciate that. My remarks are based on the work I've done in collaboration with colleagues at the Levy Institute and elsewhere. I think today morning I counted 6. Tom Masterson, Michaelis Nikephoros, Ipek Hilkarakjan, Emil Memes, Valerie Ekual, and Luisa Nassif Paris. So it's also good to be, I don't think I've ever been so many with my co-authors at the same conference. So it's a really good experience. But I have to say that the responsibility for anything outrageous or trivial that I say today rests completely with me. You can't hold my co-authors responsible for that. Now, I think there was some miscommunication between us, Tom, about the title of what I was going to talk about. I'm sorry about that. But I'm definitely not going to talk about economic well-being, although we could in the question-answer or in the discussion session. I'm focusing more on the whole idea of engendering policy models. And I'm going to pick up on 2 themes, one about theory and focusing on the theory that underpins what is the dominant game in town, which is computable general equilibrium models. And then I'm going to turn to a methodological consideration, which applies to the mainstream and the non-mainstream models. Empirical policy modeling should be guided by theory. The internal consistency of the theory underpinning the modeling, and whether it speaks to observable facts relevant to policies are therefore crucial. In the first part of my presentation, I will assess whether the efforts to integrate gender into marginalist general equilibrium policy models from this perspective. For this purpose, I will use a simple general equilibrium model that represents the analytical essence, I think, of these efforts to include gender considerations. The second part of my discussion starts out with the point that empirical policy modeling should incorporate engendering from an intersectionality perspective. Gender inequalities and outcomes are often intertwined with other forms of inequality, such as those based on class, race, ethnicity, caste, and more. Focusing on inequality between subgroups should not come at the cost of neglecting intra-subgroup inequalities when evaluating policy impacts. This methodological consideration applies to both heterodox and mainstream models. Okay, to start with general equilibrium, the setup is as follows. All standard assumptions of the basic marginalist theory are assumed to hold. We have a large number of households, say N. There are 2 factors of production, female labor and male labor. There are 2 commodities, X, which is produced only inside the SNA boundary, and H, which can be produced inside or outside the boundary, like, for example, childcare. The endowments of each household consists of the potential labor of women and men, which is measured as the maximum amount of time that can be allocated to work either inside or outside the SNA production boundary. Our households have well-behaved unitary utility functions. So they maximize utility according to the quantities or the mix of the SNA good, the non-SNA good, as well as the leisure enjoyed by the female and the male members of the household. So leisure is simply potential labor minus employed labor. Finally, turning to the production side, we have production functions that are described by the output of each of the industries are related to the male and the female labor employed in each of the industries. Given the assumption of perfect competition, each industry consists of a very large number of small identical firms, so aggregation is not an issue. The conditions for equilibrium in this type of setup are well known. The important question is whether these conditions make economic sense, not just from an alternative theoretical point, but from the point of view of the theory itself, of the general equilibrium theory itself. Whether do they make sense? Now, to get to that, we need to consider that well-behaved demand functions, factor demand functions, are essential for determining the gender allocation of SNA and non-SNA work and of leisure between men and women within this framework. To achieve well-behaved demand, we need to assume certain things about the technology of the two industries. So the question is, what are those assumptions? Do they make sense or not? Again, sense is defined as coherence within the theory. Now, before we get to that, let's just note that cost minimization in this type of a framework means certain things, right? A perfect competition in the factor markets would mean that men's wages are the same in both industries. The same holds for women. So when costs are minimized, the ratio of the marginal products of male and female labor in the two industries will be identical because both would be equated to the same factor price ratio. Right? Therefore, we can use the production function of either industry to qualitatively characterize factor demand functions within this framework. So I'm not going to use any particular notation to distinguish between industries. Following the standard analysis, we can show that the factor demand, the factor substitution matrix is given by the inverse of the Hessian matrix with, I believe, obvious notation here as to what those symbols mean. Now, if that inverse exists, we know that the factor demand functions will slope downward to the right, meaning that the principal diagonal elements of the factor substitution matrix will be negative. And they will also imply symmetry, an economically dubious property, but an inevitable result of the marginalized cost minimization framework. Now, to make matters concrete, let us suppose that the technology is Cobb-Douglas, right? Then we can show that the existence of the matrix there on the right side depends or really boils down to two conditions, right? So those conditions can be expressed in terms of the inequalities that are shown for H1 and H2 in the bullet points here. Now, if there are decreasing returns to scale, that is, if the exponents of the production function, the sum of that is less than 1, we have decreasing returns to scale, and the two conditions will be satisfied. But if you have constant returns to scale technology, then the exponents will add up to 1, and we can see that that would mean that H2 will be equal to 0, and the condition will not be met. The question then is, which is the reasonable assumption regarding technology, right? Now, it seems implausible to me that in an economy with just male and female labor as the only factors of production and a large number of households, there will be decreasing returns to scale. In the neighborhood of equilibrium, there is really no reason to expect that the technique combining male and female labor cannot be replicated to supply a little bit extra of either commodity. For example, if the non-SNA commodity is childcare, the additional demand generated by an extra few kids could be satisfied easily by deploying male and female labor in the same proportions holding previously. So, however, the constant returns to scale poses problems for engendering. The key parameters in this exercise are households' subjective trade-offs between the SNA and non-SNA products. Further, the subjective trade-off between leisure and labor is also a crucial parameter of the theory. For these preferences to matter, changes in demand conditions should influence the equilibrium allocation of male and female labor between the two products and between labor and leisure for both men and women. This link is broken when constant returns prevail. In other words, the so-called non-substitution theorem takes over. Household demand and endowments cannot affect the allocation of male and female labor between SNA production, non-SNA products, and leisure. Okay, let's set aside this issue and assume that decreasing returns do exist in the model. This would allow the familiar principles of substitution production and substitution in consumption to do their job, to bring about the supply-demand explanation of the allocation of male and female labor. But there is no way to exclude, even when all the assumptions of the theory are satisfied, the existence of multiple equilibria. I illustrate this using a numerical example of the general model that I just sketched. The result is shown in the slide for the SNA commodity. Excess demand for the commodity is plotted on the vertical axis, and its price is on the horizontal axis. Let us recall that general equilibrium happens when excess demand equals 0. As we can see, the white line depicting excess demand cuts the horizontal axis at 3 different points, which indicate 3 different equilibrium prices. Well, equilibrium prices in marginalist theory are ultimately indices of relative scarcities. It's theoretically incoherent, I would argue, to postulate that the same set of endowments and preferences can result in very different price vectors. So the supply-demand explanation of the allocation of male and female labor and the distribution of income among households in our model once again seems to have arrived at a theoretical dead end. As many of you may recognize, what I've illustrated is the well-known Sonnenschein-Mantel-Debroux theorem, which Alan Kerman famously described as a palace revolution and not a revolt of the lower classes. That is the class to which most of us in this room belong. So let me just turn to methodology now. Let me begin by saying that I wanted to actually begin this part of the presentation by recalling this conversation that I had with Sue Himmelmeit, who is here, several years ago at the 100th anniversary of the CJE, of the Cambridge Journal of Economics. And I believe that was the first time that I met her. And I was presenting some work on economic well-being at that time, and which uses the household as a unit of analysis. And around 20 years ago, prior to that, the notion of the head of the household was dropped in the US Census Bureau surveys, and that switched to this idea of the householder. So, which meant that it's not necessary that in a married couple household, the husband will always be designated as the reference person, as the householder. So Sue was jokingly telling me that when the head of the household designation was being used, she wanted to shoot the household head So in a similar vein, I want to say that I want to shoot the representative agents, and I'll try to explain why I'm saying what I'm saying. Now, in models assessing gendered outcomes, the concept of representative agent is very common. The idea is not limited, as I said before, to marginalist models. It also appears in some non-mainstream models. So the standard way to evaluate distributional outcomes proceeds by like two axes of differentiation in standard models. There is a distinction between factors, like I discussed the example of male and female factors. You can go finer. You could distinguish between male, rural, female, rural, and whichever way you want to cut it. Or it's like between different types of households. Again, you can deploy a very detailed taxonomy or a less detailed one, depending on what the purpose of the modeling is. Now, what do these representative agents do? Well, that depends on the theory. In general, they supply labor to various sectors of the economy, produce non-essential services like childcare, purchase commodities, including like acts of saving, purchase of financial assets or the others, and engage in leisure activities. Now, the main limitation in this methodology concerning inequality is that it cannot capture within-group inequality. Now, it turns out that most macroeconomic shifts typically lead to changes in both between-group and within-group inequality changes. Usually, the within-group change is more dominant than the between-group inequality changes. So therefore, relying on the representative agent approach would be equivalent to ignoring the intra-group inequality, which often is the most significant factor that affects changes in inequality. So more generally, the point is that intersectionality involves looking at outcomes through the lens of inequality across subgroups and inequality within subgroups. So this would mean, for example, to illustrate with a practical example, that if I were to study the distribution, the macro and the distributional outcomes of, say, a policy which liberalizes the access to microcredit for women, say in India, I would want to look at that not just in terms of men and women, let me start again. Generalizes, microcredit, liberalizes microcredit access to all. So I want to look at the outcomes in terms of men and women, but I also want to look at women by caste, by upper caste, by OBC groups, by SCs, the scheduled caste and the scheduled tribes. But I also want to look at the inequalities within each of these groups, because we know from studying the political economy of India over the last 30, 40 years, that a significant, what's called in India as a creamy layer, which is a rich or a relatively rich, rich, among the previously disadvantaged groups have emerged. You find the same phenomena when you study racial inequality in the US. It's important to pay attention to the within-group inequality too. Sorry? That's plenty. Okay. Now, a sensible alternative, I would argue, is to replace representative agents with a representative sample of households and individuals. This is what we do in the Levy Institute microsimulation models developed by Thomas Masterson, with perhaps minimal input from me and other colleagues. Let me illustrate the difference between the two approaches by sharing results from our upcoming study on Mexico, part of which looks at the effects of implementing a universal elder care program in Mexico. I want to present the results about earnings. Now, our model generates the entire post-intervention earnings distribution, enabling us to estimate or say something about how the program might impact workers at different parts of the earnings spectrum. Conversely, a representative agent approach would only provide us with the post-intervention average earnings. Now, how can we say anything about workers at the different portions of the distribution if we were to use the representative agent method? Well, a usual strategy here is to assume that earnings follow a standard distribution. A common and a reasonable choice is the log normal distribution. Making this assumption and using the post-intervention average wage, along with the pre-intervention variance of the wage, allows us to generate an estimated, an artificial post-intervention earnings distribution, right? So then we can compare that post-intervention earnings distribution created by the representative agent method compared to the full model or the RA method, right? So that's what is shown in the next figure. So the figure compares these two methods, the results from these two methods. The symbol, like the notation Levy, represents our microsimulation results, and RA stands for the representative agent method. Now, because the RA method drastically overstates the distributional shifts, the changes that happens between men and women across the percentile groups by our method seems quite small, but they're not really that small. But they're definitely smaller than the RA method. Given the nature of the Universal Elder Care Program, it's difficult to believe that the changes produced by the RA method are anywhere near the ballpark of what would be considered as reasonable changes. I would argue that our assessment that the overall distribution will see not such drastic effects is perhaps a more reasonable assessment. Thank you very much.